Hello and welcome everyone to the lecture series of the course titled An Advanced Non-Orthogonal Multiple Access Security Technique for Future Wireless Communication Networks. In this lecture, we will be discussing about the proposed algorithm and the mathematical equations, mathematical model of the proposed NOMA security scheme. So in the proposed algorithm, as we told that we have two antennas A1, we name the antennas as V1 and V2 at the transmitter side, and the superimposed transmitted signal from antenna 1, that is the X1 superimposed with M1A, and X2 superimposed with M2B, can be written as follows. This is the transmitted signal, M1A the precoder, X1 the transmitted data packet. So superimposed precoder with the data packet, M1 X of the user 1, and superimposed data packet of user 2 and its respective precoder superimposed from combinedly sent from the antenna 1 can be written as follows. Similarly, from the antenna 2, the user 1 signal and user 2 signal superimposed with their respective precoder matrices can be written as follows. Transmitted signal from antenna 2. So again, the transmitted signal of the M1A is the precoder matrix superimposed with X1, M2A precoder matrix M2A with superimposed with X2, that is the transmitted data packet of user 2. Similarly, X1 with M1A, X2 with M2B. Transmitted signal from antenna 1, transmitted signal from antenna 2. So Y11 is the received signal. Y values are all the received signal. The Y11 is the received signal at user 1 from antenna 1. Y21 is the received signal at user 1 at from antenna 2, and eavesdropper, we consider eavesdropper as the user 3. So eavesdropper also receives a signal which is a degraded one. So the received signal at eavesdropper from antenna 3 from antenna 1 can be written as follows. So receive signal at user 1 from antenna 1, receive signal at user 2 from antenna 1. Sorry, this is the receive signal at user 2 from antenna 1. And this is the receive signal at user 3 from antenna 1, that is the eavesdropper. Similarly, here is the receive signal at user 1 from antenna 2, receive signal at user 2 from antenna 2, receive signal at user 3, that is the eavesdropper from antenna 2. So H11 is the channel between user 1 and antenna 1, H21 the channel between user 2 and antenna 1, and H31 the channel between user 3 eavesdropper and the antenna 1. So similarly here H12 is the receive signal at user 1 from antenna 2, receive a channel between user 2 and antenna 2, channel between eavesdropper and antenna 2. Here the denotions are given. So the combined receive signal at user 1 is written in the equations provided in the slide. The combined received signal at user 1 is the received signal from antenna 1 and antenna 2, and here we have separated the data of x1 and x2. The x1 is the desired term for the user 1, while for user 2 the x2 is the desired term, while the first term is the interference term and it can be denoted with the zero matrix. For eavesdropper, both the terms are desired for it. So the denotions are given here as follows. For M1, for now the task is to calculate the specifically the intelligent precoder matrices that will be superimposed with the transmitted data package. For that purpose, we will be equating the desired term with the identity matrix of user 1 and the interference term of user 2 uh, with the zero matrix. Similarly, the for M2A and M2B, we equate the x2 interference term with zero matrix and the desired term of user 2 with the identity matrix. Now solving these equations simultaneously, we can easily find out the matrices M1A, M1B, M2, and M2B. And we consider the desired term of user 1 as an identity matrix and interference term of user 2 as 0, as served them jointly to get M1A and M1B. Similarly for user 2, and it is written inwards here. So the mathematical performance analysis of the signal to interference plus noise ratio is provided in the equations through the formula as follows, where we can easily see that there is a degradation in the signal to interference plus noise ratio of both the receiver one eavesdropper, like both of the eavesdropper. Yeah, eavesdropper that is trying to eavesdrop the information of user 2, and there is a degradation of the in the information that is intended for user 2, but the eavesdropper is trying to eavesdrop it. We can easily see the degraded signal to interference power noise ratio. So the advantages of the proposed algorithm is that it provides security against external eavesdropping, security against the internal eavesdropping. It is less complex, it requires limited processing, it enhances the complexity for the eavesdroppers. The proposed method can provide security against eavesdropping because the precoders are dependent on channel of the legitimate nodes. The proposed algorithm can also provide security against internet dropping by ensuring that there will be no information among users. That's true. And due to the diagonal channel matrices, the inverse operation is simple. Hence, precoder matrices can be designed by simple computation. As we have previously seen in the past slides, yes, it does not require much computation, and there is no need for interference cancellation because we transmit the signal simultaneously from two antennas at one time, and there is an automatic interference cancellation due to specially designed precoder matrices. And the mixture of channel-based precoder matrices of the two users that transmit simultaneously from two antennas, it is more challenging for the eavesdropper to eavesdrop compared to the channel adaptive secure transmission based on single user. So these were the advantages of the proposed algorithm on, and that's it for this lecture. In the next lecture, I will be discussing about the MATLAB implementation of this proposed algorithm. So I hope you are following up with this lecture and finding it interesting. So see you guys in the next lecture.